Hey everybody, it's Gavin with Vintage Computer Center and Arcade Dog Bell again with part 4 of building the FujiNet. Today's video is going to be flashing the FujiNet. Once we get to the stage that we're currently at, I like to flash them to make sure that the microcontroller will take the program, make sure the USB connection is actually working. I prefer doing that before I finish the unit in case I discover a problem. It's easier to troubleshoot when there's less devices on it. And then we'll attach the SIO plug on the unit. Pretty simple, some time consuming, but relatively simple step. And I hope you enjoy, and make sure, I appreciate all your feedback. I've gotten quite a bit of feedback on the first few episodes. So, keep sending the feedback. I love hearing from you guys. And with that, let's get to work, Bill. Okay, you ready? Okay, what I like to do before I flash them is I stick an SD card in here that's already been in a working FujiNet. It has a config file on there, so it'll automatically attach this to the Wi-Fi if it works. It's just one other way I like to test these. So we've got it plugged in. I've got the flashing software on. We'll turn it on. And as you'll notice, the lights come on. All three lights come on dimly. And we'll hit the flash firmware button on the software, and it is now flashing. See if we can move it over here. First thing it does is erase the flash, and it does take a little bit of time to erase it. And now it has erased it, and it's writing the images and verifying the hashes. This takes a moment to do. And hopefully, if it flashes correctly, it'll restart, all the lights will go off, and the white light will come on bright, signifying that we've got a Wi-Fi connection to my Wi-Fi. That's the goal. And then we run a couple other tests just to make sure that it's working by pressing the different buttons. Almost there. Okay, arcade dogs, hush. It's got one more, yep. And then it's flashed. We'll put it on the serial debug mode. And boom, there's the bright white light showing that we've got a Wi-Fi connection. So press it one time, get a short press, it shows image rotate. Press the B button once, it puts into tape debugging mode. 2 clicks on the B button gives us some debug information. Long hold on the A button shifts it over to Bluetooth, and you can see the Bluetooth light is now lit. Quick one on the A button again changes the speed of the Bluetooth. We can rotate through the speeds. Long hold on the B will do a reset. And then we're connected back to the Wi-Fi. And then the reset button over here will do another reset. Reboot it, and we've got the Wi-Fi light enabled. So this FujiNet's passed the flash. We know that all the button capabilities are correct, and it is running the FujiNet software that's the way it's supposed to. So our next step is to put the SIO connection in here and connect to the computer and make sure that it works on the computer. And once it passes that, we'll put the SIO connection on the other side, and it'll be good to go. So stay tuned. So we've got the FujiNet about 80% completed. We've got all of the major components installed on it. We have it flashed. We've tested the flash to make sure that it can connect to the Wi-Fi, it can connect to the internet because it's getting the time server, so we know the functionality of this thing is good to go. The next thing we've got to do is make our SIO connections. These are 3D printed parts, and they take quite a bit of time to actually get them ready to be useful. Since it is 3D printed parts, they're not perfectly printed. There's some, junk that gets in the way that we need to clean out of these things. We need to ream the holes for the pins. We need to place the pins. And then once we get it all this built, then we have to attach it to our FujiNet. This is probably the longest process of all of the steps of creating this little device, because it does take some time to clean up these prints and get them ready to go. We use a couple of these little tools. These are actually reamers for my desoldering iron. They allow you to slide in through the tip of the desoldering iron and clear out any solder that may have accumulated in there, but I found that they're absolutely the perfect size for reaming the holes in this thing. So let's get started. I'm probably going to fast forward through bits of this because like I said, it does take some time to do. But we're going to do the socket first and then the plug because I've learned a little trick that once you put the pins in the socket, you can put the plug in the socket and place its pins in there, and you've got a piece that's joined together and holds the pins all in the correct locations. Because I have noticed that if you try to do this one separately, there's nothing for the pins to grab onto, so the pins tend to just fall out. So trial and error, that's one of the things I learned many months ago when the very first FujiNet that I built was, how do I get these pins to stay in? Oh yeah, if we connect that, it works great. So we'll start off, we're going to ream out. Let's get rid of our FujiNet. I'm going to ream out the little holes that are in the socket here. Just have a little bit of plastic that gets in the way while it's printed. And I'm going to cheat because, again, I'm over the age of 45, so my eyes aren't quite as good as they used to be. But this lit loop really helps. Now, this is just a matter of shoving this reaming tool through each of the pinholes. You don't want to do it too much because you don't want those pinholes to get out of round and also get them too big that the pins won't stick. Okay, those are good. Sometimes you need to clean out a little bit of these holes with an X-Acto knife. Some stringing might happen with the 3D printer. Depends on the temperature. I've learned that now that it's colder, I'm getting a lot more stringing in the 3D printer, and having the 3D printer out here in the garage has proven to be problematic. So I've moved it back inside the house where it's a little bit warmer and the prints are turning out much better. So these are the first pins that we use. We get these from DigiKey. They're quite expensive. I've tried sourcing cheaper versions of these little guys, but I can't seem to find any that are less expensive. But you know, the combination of all the pins that are in one of these SIO connections and the plastic and the time it takes to make it, these are, you know, $5-6 worth of parts in here. And you wouldn't think so because the bulk of it is 3D printed plastic, but those pins are expensive. So I tend to bend down and look for them if I drop one. You know, they're really tiny. I doubt you'll be able to see it on here, but they're gold plated, just a little pin. But they are ingenious. When Moz decided to build it this way, I mean, it was just ingenious the way he used these pins. That was my biggest fear with making anything with SIO, is how you make the connections, because unfortunately Molex doesn't make those connections anymore, and your only options are to 3D print. So it was great that he figured out a way to make this socket and the plug so we could have like a daisy chain SIO connection on these. I did learn that, however, that if you don't want to plug this directly into the Atari computer, or if you want this at the end of the chain, you can plug an SIO cable into this side of it, and the Fuji drive or the FujiNet will work just fine. So it is 100% pass-through. It doesn't matter which side you plug the cable into, it'll work. That's kind of nice because some people don't want to put these in the back of their computers or on the side of their computers. You can actually hook them in backwards with an SIO cable and it works just fine. Try to be careful with these pins because, again, they're not cheap, so I don't want to break them if I can avoid breaking them. Generally they fit in there quite nicely. Sometimes you may need to ream the hole a little bit more. Trick is finding out where the pin actually lines up in the inside of that hole to come through. But those are a piece of cake. I wish the SIO plug was as easy to do as this SIO socket. I really do. Because the SIO plug is what takes me a long time. And you know, I've got a good 3D printer. I've got the Prusa 3D printer, and it prints high quality, but there's something about this SIO plug that there's a lot of stringing in it. So you've got to really clean it up inside in order to get the little sockets to fit into their spots. This one doesn't feel like it's going right, so let's flip it back over and check the hole. Yeah, there's still a little plug in there. I actually felt it come out. Okay. Okay, 13 pins in our socket here, so we're good to go. You may have to adjust them a little bit. Sometimes their alignment is a little off, but luckily it's pretty forgiving, so they tend to get pushed into place. And now we got to do the cleanup work on this before we can start placing the little metal sockets in there. Get that out of the way. And by cleanup, generally I take a lighter in here and burn some of the light stringing that has developed during printing. And then I go in with my very sharp X-Acto knife and I ream the backside of these holes because there is a tremendous amount of stringing. I tried showing it on camera, but there's no way you can see it because it's black and dark in there. But there is a lot of 3D print material in the way of the opening. So just take these, open up the holes. And I'm not really putting any pressure on it because I don't want to increase the size of the hole. I just want to clean the crud out of the way. It would be nice if we could afford to do some injection molding on this, but setting up the tools for that are ridiculously expensive. You know, as I mentioned, this set of plug and socket is about $5 worth of parts and material, not including the time it takes to build it. But for injection molding, you're looking at usually $10,000 minimum to get the die set up, and that's just for one of them, either the socket or the plug. It's not for both. So the cost would be astronomical, and no one would want to eat that cost. Not for this small a run. I mean, if we're making several million units, then yeah, maybe, but yeah, for a few hundred or even a few thousand, it's really not worth the cost of having injection molding done. I actually looked into that a few years ago for SIO plugs for the FujiNet, or not for the FujiNet, for the SIO or the S-Drive Maxes, and I was floored with how much it was going to cost. You know, I said it was about $10,000 for, actually for the SIO plug that goes on the S-Drive Maxes, it was $10,000 per part. So you've got the two outer clamshells, so there's $20,000 there, and you've got the inner SIO connection like this that goes in it, and that was another $10,000 for that. So you got $30,000 just to tool to make an SIO plug for SIO cables, and then you've got the cost of production. And they had quoted me something like $7 or $8 a piece for making them. So I figured, you know, no one's going to want to spend that kind of money that I would have to push through the cost wise, and I gave up that dream and just continued 3D printing them. 3D printing them is not perfect, not at all. There's issues with 3D printing, but it does the job, and it's relatively inexpensive. Takes some time. Like these, I can print 10 sets at a time on my printer, and it takes 22 hours to print 10 of these. So it's 20 pieces. It's 10 females or 10 sockets and 10 plugs. Okay, and we just slide that in. Make sure that these pins are still pushed in, and that this is completely up against the back, so we know we've got a good seat. And then we take the other connections, which are little metal sockets. If anybody's interested, I know the manufacturer part number on these sockets is 7-745288-2, and it says socket gold solder. And then the pins are 5-745-287-4, and these are pin gold solder cup. Again, these little guys are not cheap. You get 540 at a time, I think it is, which is enough for 40 sets of these, and it's almost $200. And this is the tricky part, because a little bit of plastic could still be in there, and these guys don't want to go all the way if that's the case. So you just got to be gentle with them because these will bend and then break quite easily. And again, they're too expensive to waste, so I try not to break any if I can avoid it. You want to make sure that both sides get pushed in nicely. And forgive my sniffles. I believe I got a little bit of a cold going on. No, it's not COVID that I'm aware of, thank God, but definitely have a little bit of the sniffles. It's probably from being out here in the ice cold garage working on these things too much. And the pins won't be, perfectly aligned on this side, but that's fine. We can get them into the FujiNet without too much of a problem. The idea is just to be gentle, not to force it. If one's giving you a little bit of resistance, what I often do is I'll go pull the pin out on the other side and kind of blow it out. Make sure there's nothing stuck in there and then try it again. And these things are extremely sharp, so again, I've learned the hard way a few times. Don't push too hard on it with your finger because it will embed itself in your finger. Can't tell you how many of these things I've jammed into my thumb. Perhaps a thimble would be useful in this kind of situation. To use for sewing, something to put on there to push down on without puncturing your finger. And again, if I find one that's being a little difficult, I skip it and go on to the next one. I get all of them in that I can get in without too much force. And then I'll pull out the pin on the other side and clean it out and see if that makes any difference. That one, definitely some issues there. Okay, so we've got a number of these that aren't working. So we'll pull out the pins. I just pulled out one that was working. Remember, it's a mirror image, Gavin. It's not the same. Try not to bend these too much. The more you bend them, the higher the possibility that you're going to break it one of these times. And again, they're not cheap, considering how little they are. Like you think you pay for how big something is, and you definitely don't with these little pins and sockets. So just kind of blow it out. I will hold it up to the light and see if I can see light through it. Once these get stabilized and soldered onto the board, it's usually not a big deal, but until they get stabilized, they are kind of fragile. Clean that out. And if somebody's got an idea how to do this quicker, let me know. I'd love to hear it, but I have yet to find a way to do it quicker. So out of all the steps of building these things, this is the step I really don't like. What I'll tend to do is, on a day that I've got nothing else going on, I'll try to build ahead of these. I'll try to make 20 or 30 of these things in advance and keep them in a Ziploc bag with a one of those little anti-moisture packets. Silica gel's one of these. And that way I've got a bunch, so when I need to build more devices, I've got them ready to go, and it quickly increases my build time. But we ran out of these pins, so I had to wait until we got some pins in. But there you have it. We have one complete unit. Let's make sure we're not missing any. Yep, they're all in there. Got the socket and the plug, and this is ready to attach to the FujiNet like this. This is what it looks like when they are actually attached to the FujiNet. So we're ready to take this little guy and attach it to this, and then perform the next step. Like I said, what we do is we'll put the plug side on here, and then we'll put it in the computer and we'll give it a shot and make sure it works. We'll try loading an image off of the SD card, and we'll also load an image off my my private TNFS server to make sure that it works over the internet. And once that is accomplished, then we put the JTAG on, then we put the socket on, and then we clean it up and put our sticker on, and we're good to go. It's ready to be cased. So stay tuned for the next step. So it'll be mounting this to this and testing out the FujiNet again. Okay guys, that's the end of part 4. It looks like this is going to be a 5-part series in building the FujiNet, but the next part we should finish it and be ready to ship them out. So I hope you've enjoyed this. Please like and subscribe. We're a new channel, so we're still learning. You know, pardon the quality. It will get better, I promise. You know, I do appreciate all the feedback that I've gotten and the helpful suggestions. It's been great, so please keep it coming. But if you could like and subscribe, I'd really appreciate it. We're trying to make this channel grow and bring more interesting content from the vintage computer world. So again, thanks for watching. Go check out part 5 when it comes out and see how we finish building the FujiNet. Thanks. Say goodbye, Bill. Bye, Bill. Bye, you guys.